Welcome once again to my YouTube channel. I'm here to talk about, as usual, something very interesting. Okay, um, your mobile phones, your laptops, your palm tops, and you name it, devices that make life, worth living sometimes. They are with you today, and they've become part of us, and we enjoy what they do for us. Some of them, like our phones, have turned to our calculators. Our phones has also turned to our reminders, and our phone has also turned to that annoying device that wakes you up in the morning. I'm talking about your alarm clock. All right. So it does quite a lot of things for us, and it's a part of us today, which I'm sure you agree with me that we cannot do without these things anymore. All right. You don't test them, you don't see how they work, and it has come to stay. Okay. But sitting inside some of these are exciting and beautiful devices are some faithful components we know as transistors. We call them transistors. Okay. Now, in your palm tops, your laptops, and your mobile phones, we have billions of them arranged in different patterns, different ways, in different configurations to do different things. All right. So in today's video, I'm going to be showing you the different packages they come in. I'm talking of transistors now. Different packages they come in. How you can test them, and of course how they are used. Okay, so sit back, relax, pick up your piece of paper and of course your pen, and join me. Let's do this together. And just in case you are a visitor to my channel, just kindly click the subscribe button. That gives us an encouragement to continue to do this beautiful work. So sit back, relax, and please pick up your pen and your piece of paper, and let's do this together, shall we? All right, welcome back once again. Uh, okay, let me just start with the packages. All right, there are different packages for transistors. This is one type of package. This is another one. This is another package. This one is another package. This another kind of package, and this another one. Um, in my roughly 15 years of actively um, doing electronics professionally, these are the most common ones I usually come across. Okay, so I'll just discuss them with you. There are many other packages, many other packages. There are some that are called SMDs. Okay, that's surface mount devices. On demand, I could just do a video on that, but let's just focus on these ones. All right. Now, if you notice, all of them, they all have three terminals. Three terminals. All right. Every transistor would have three terminals. Now, let me quickly state that there is another kind of transistor known as the MOSFET. Okay, I'm going to do a video on that, but today we'll be looking at BJTs, and BJTs, that's BJTs. All right, BJT simply means bipolar junction transistors. Okay, so we'll be looking at BJTs today, and all of these ones we have here are BJTs. All right, now like I said, they have different packages. All right, this one is your TO92 package. TO92 package. And the number written on it, I'm not sure you can see that, but let me just tell you, it's a 2N5551. Okay, now all transistors would have a part number. It is that part number you use to search for its data sheet online, and then it's the data sheet that will give you a lot of other information about that particular transistor. Just in case you want to search for the data sheet, you could just type into your Google search bar 2N5551 transistor PDF. Okay, 2N5551 transistor PDF. You see different options, so you choose the one that has PDF attached to it, and then it gives you many information about that. I think let's just quickly do that now. Now let me go to my browser. uh, 2N, let me 2N 5551 transistor PDF data sheet. Okay, so let's see. That's my channel. Okay, there are a number of them here. Okay, let's see what that gives us. So this is a data sheet that gives us a lot of information about this particular transistor. You see that the number is written there, and it tells us that it's an NPN transistor. And then if we come down to look at this part, it tells us the pinouts, that pin 1, okay, pin 1 is the collector, and where is pin 1 here? Now, this tells you that if you are looking at the transistor from the base, meaning that, there's a curved part here. So if this curved part, if I'm looking at it from under like this, let's try to stand it there, beautiful. Now, if I'm looking at it from under, this is 1, this is 2, and this is 3, okay? So 1 is your collector, 2 is your base, and 3 is your emitter. Okay, and of course, we know that this is the circuit symbol for a transistor. All right, circuit symbol for an NPN transistor. So this is the transistor, and I think you see that it gives you information about the package TO92, like we've already stated before. All right. Now, this is an NPN transistor. So if you want to check for the detail of every other one, you can just go online and search the way I just searched. It's going to give you a lot of information. You see that we have different collector base voltage, the collector emitter voltage, emitter base voltage. Okay, now we'll look at that in a bit, but this tells you the data sheet tells you, gives you an information of the transistor and all of its electrical characteristics, and of course information about the dimensions of the transistor, the measurements of different parts of the transistor. I think that would be somewhere around here. You see that this gives you also the dimensions, different measurements of the transistor. Just, it's more like the what's the word now? It's more like the what do they call this now? When you buy a new electronic device, the paper that comes with it is called a manual. All right, this gives you this is more like the manual. The data sheet for a component, it's more like its manual. All right, now, since we have an information about this particular transistor, and we know that it's an NPN transistor, so 2N5551 is an NPN transistor, where from the data sheet we know that this is the collector, this is the base, and this is the emitter. Now, if we want to test this transistor to be sure it is fine, okay, what we do is we put our multimeter in the diode range, okay, diode measurement. Now, this one is just on my meter is continuity test. So I'll just press this to give me the diode measurement. Once you see this symbol on your meter screen, it tells you that that's your diode measurement. So whenever you want to test for a BJT transistor, you make use of your diode measurement. Okay, and now it will make sense now if I put it this way. Every transistor looks like two diodes arranged back to back. Now let me tell you what I mean. Now you see this particular diode. If I decide that I want to put another one like this, and then I tap out this center, this is one terminal, this is another terminal, and this is another terminal. Now also I can decide to arrange it this way, such that this is like this. You see that this is one terminal, this is another terminal, and this is another one. Okay, so you see that it's more like two diodes arranged back to back. All right, So if you have that at the back of your mind, it helps you to be able to test, with an understanding of what you are doing. Okay. Now, and that is why we put our switch ammeters to diode measurement whenever we want to test a transistor. So let's quickly run a test on this 2N5551 and let's see if this transistor is fine. Now, the first thing you need to know about any transistor is that when it is not switched on, okay, I'm going to mention the fact that transistors are used as switch. Let me quickly say that they are used as switches. And what that switch simply does is this. Now, BJT transistors are current controlled. So let's assume this is my 2N5551. Okay. Now, we know this is the circuit symbol of a transistor. This is the collector, this is the base, and this is the emitter. All right. Now, if a current flows from base to emitter, if a current flows from base to emitter, more current will flow from collector to emitter. Now, it simply tells us that this base emitter current, okay, is what would make this transistor switch on. Now, let me give you an idea of what I'm talking about. Now, anything that happens between the base and emitter will make the collector and emitter act like they are connected together, more like what a switch would do, isn't it? Such that this is one point, you call it the collector, and this is the other point, the emitter. All right. Now, if current flows between the base, from base to emitter, okay, the collector and emitter will connect. And once they connect, we say that the transistor is switched on. All right. I'm going to teach in another video on how you can bias transistors, meaning how you can connect transistors for them to be used as switches. You can also use them as amplifiers. All right. But this is the basic way they work. Current needs to flow from base to emitter for more current to flow from collector emitter, meaning, like I said, that if current flows this way, then this and this acts like a short circuit, meaning that if it is not switched on at all, there shouldn't be any connection between your collector and emitter, telling us that there should be high resistance, okay, in mega ohms range between what your collector and your emitter. Okay. Now, we know that this is the base and this is the collector and this is the emitter for this particular transistor. So the first thing we do is we switch our meter for us to test. We switch it to continuity mode and then connect it across collector and emitter. There mustn't be any contact between the two of them. Okay. Now, if that is the case, then we know that the collector and the emitter are not shorted, meaning that they are not joined together inside it. Most times, if your transistor is bad, your collector and emitter is joined. Okay. Now, that's the first test. Then the second test. Okay. Let me just give you this key. Already, we know that this is an NPN transistor. Okay. This is N means negative, negative, negative. P means positive, obviously positive. And the other N means what? Negative. Okay. So if it is an NPN transistor, it means that when we want to test with our multimeter, switch it back to your diode test, like I said. When you want to test with your multimeter, okay, your positive appeared once in the whole NPN naming, okay? So if this appeared once, you take this positive probe and put it on your base. And then you test your collector, you get a reading, okay, about 0.664. That basically is the voltage drop required for this transistor to come on. Okay, that's a collector base. Okay, no, not really, because like I said, it's base emitter. Okay, now this is a voltage drop and this is another voltage drop, 0.669. Now this is the minimum voltage drop required, okay, between your base and the emitter for this transistor to switch on. All right, now let's do this again. Put it there, put on your collector, you get a reading, and put on the emitter, you get another reading. Another thing you should take note of is this. You'll find out that the reading you get between your base and the collector would be less than the reading you get between the base and the emitter. You see, this is 0.669 and this is 0.664. All right. Now, this is a key, just in case you don't really know the kind of transistor, okay, or the terminals of the transistor. You can use this to know. There's always a higher reading, okay, between your base and your emitter. So let's take it again. This is collector, of course, and this, and the, come on, and this is your emitter, okay, 669 and 664. So this transistor obviously is fine. Now let's just switch the terminals. We shouldn't get any reading now. Okay, now like I said, it's an NPN transistor, so on the negative probe we get 2 readings, but on the positive probe there shouldn't be any reading now. There shouldn't be any reading now. Shouldn't be any reading. You see, so that's how you test your transistor. Now we're not going to searching for the data sheet of all this, so the video will not be unnecessarily long. Okay, but already I have checked the data sheet of these other transistors, and I already know their pinout, okay, because I've been using them for years. So I will quickly tell you the pinout, the kind of transistor, and we'll just run a quick test to know if they are okay. All right, now this is 2SA1943. It's written on it. Just in case you can't see it, let me write it out. The part number is 2SA1943. Okay, now another key I want to make you see is that from experience I found out that any part number that starts with A before the number is usually a PNP transistor. Okay, once it starts with A, it's a PNP transistor. Once the part number starts with C, if it starts with C, for this case, it is what? An NPN transistor. So this, of course, 2SA1943 is a PNP transistor. And already I've checked the data sheet and I know that this is the base, this is the collector, and this is the emitter. So this is 2SA1943. This is the collector. Sorry, this is the base, this is the collector, and this is the emitter. Now, it simply means that if I want to test this, the first thing I do is to test for short circuit between the collector and emitter. So it's not shorted. It means that it's not joined, which tells us in the first place that we can continue with our tests. Now, the next thing is to switch it to diode measurement. And then, knowing that this is PNP, it means our negative probe would be on the base. Okay? Now, we'll get a reading, base collector, base emitter, base collector, base emitter. Now remember what I said earlier, between base collector you get a lesser reading compared to what? Base emitter. So this is 0.524 and this is 0.527. So it tells us that we are correct. This is base collector and base emitter. All right, now if I swap these pins and try to test, I shouldn't get any reading. So this transistor is okay and it will happily sit in a correctly wired circuit and do its job happily. All right, now let's test the next one. This is C4468. Already, like I said, I've checked the data sheet and I know the pinout. This is base, this is collector, and this is the emitter. All right, and obviously, like I mentioned earlier, it starts with C, so this is an NPN transistor. Now, this mustn't be the case every time, okay, but for most of them, it's a key you get to use. All right, now if this is an NPN transistor, it means that a positive probe will be on the base. Okay, now let's see, 0.542 and 0.543. So once again, we see that this is the emitter because we have a higher reading there. All right, this one and this one have the same pinout. Okay, I'm going to test these two, and then we'll call it a day, so you can digest what we have already talked about. Now for this one, I already checked the data sheet, okay, and I know that this is the collector and this is the emitter, and this is the base. You see that the pinout is now different. So this is the base for this one, this is the collector, and this is the emitter. It's like you are reading it backwards. This one you are reading it this way, and for this you're reading it this way. Okay, so for this, let's test and see. Now, like I said, the first thing, you put it in continuity mode, and then test between your collector and your emitter. There shouldn't be any contact, so we are free to continue to do the other test. Now switch back to your diode test, and of course I know this is a PNP transistor. Like I said, I've checked the data sheet. So my negative probe will be on the base collector. I'm going to get a reading. Emitter, I'm going to get a reading. So we see that between base collector there is a lower reading, and between base emitter there is a higher reading. Okay, so take note of that. It's going to help you as you move along your journey in the beautiful field of electronics. Okay, let's just quickly test one of these. Which should I use now? Okay, let me use this. All right, now like I said, two of them have the same pinouts. Okay, now this is A1837. I hope you can see this. Let me write right here. Okay, so this is A1837. 1837. Now, from what I've said earlier, you can guess that this is a PNP transistor. Okay. Now, I've checked the data sheet, like I said, and this is the base, this is the collector, and this is the emitter. Okay. So let's test this transistor and see if it's okay. Now, the first thing, like I said, is you switch to your continuity mode and then test. Okay. So our collector and our emitter is not shorted, so I can run other tests. All right, now since it's a PNP transistor, let the negative probe be on the base. Now base collector gives me 578, base emitter gives me 587. Okay, so this is 0.578 and 0.584. We see that once again, it is consistent with what I said earlier. Your reading between your base and the emitter would be higher than the reading between your base and the collector. This is a very important key, just in case you pick up a transistor and you don't know the pinouts. Once you get a higher reading between the base and between two particular pins, you know that that is your base emitter pins. All right. Now, having said all this, like I said, there are many other types of transistors, but today, like I said, we'll be looking at only BJT transistors. And I hope you learned something. I hope you learned something. Please feel free to ask your questions in the comment section. I'll be happy to hear your comments. Just let me know what you would like me to touch. And if there's any part that is confusing, kindly let me know, and we will do a video to answer that for you. All right. Now, I hope you learned something, and just in case you've not subscribed, kindly click the subscribe button. That gives us an encouragement to continue to do this beautiful work. So, and see you some other time. All right, welcome once again to my YouTube channel, ladies and gentlemen. You're welcome. Yeah, stop it. Sitting together in billions, no, I don't like what I'm saying. Just please, let's take it again. So if you've not subscribed, please kindly click the subscribe freaking button. Shit, what am I doing?